Hey friends, make yourself comfortable because today we're taking a journey to the red planet, Mars. By the end of this video, you'll know almost everything about its history, surface, hidden oceans, and even what might happen there in the future. We'll go 4.6 billion years back, see the planet's wildest moments, and understand why Mars is still puzzling scientists today. And yes, I promise, there will be humor, crazy facts, and mind-blowing visuals. Buckle up, this isn't just a dusty rock floating in space, it's a full-blown cosmic drama. Mars formed around 4.6 billion years ago, just a few million years after the Sun ignited. Its small size was actually a huge advantage. Think of it like building a Lego model with fewer bricks, faster and easier to complete. Within just 10 to 20 million years, Mars was already a fully formed planet. Earth and Venus, by comparison, were still slowly accumulating material. Fun fact, even though Mercury seems like it should be the oldest, it's actually Jupiter that holds the title of the first fully formed planet. Inner planets formed from heavy materials like iron and silicate near the Sun, while outer planets formed from gas and ice in the colder regions. Mars ended up being the last of the inner planets, and it would face some unexpected challenges thanks to its neighbor, Jupiter. Mars never became as massive as Earth, even though it had a huge head start. The main culprit? Jupiter. Its powerful gravity swept up leftover material that could have gone to Mars. Imagine training for a marathon and your older sibling eats all the energy bars. Classic Jupiter move. So, Mars had a 50 to 100 million year advantage, but ended up as a mini-Earth, while Earth continued to bulk up. The small size would later affect everything: its atmosphere, volcanic activity, and even its ability to retain water. The Noachian era, 4.1 to 3.7 billion years ago, is when Mars was young, hot, and possibly wet. The planet had a thick atmosphere, high temperatures, and maybe even shallow oceans. During this time, large impact craters formed, leaving lasting marks in the southern hemisphere. The northern lowlands were smoother, possibly shaped by an ancient ocean. Volcanic activity started to shape the landscape. Scientists believe the first window for life might have opened during this era. There could have been microbial organisms living in the oceans or under the surface, protected from harsh radiation. Think of Mars as a teenager with all the potential in the world, still growing, still forming its identity. The Hesperian era, 3.7 to 2.9 billion years ago, brought massive changes. Volcanoes became more active, creating enormous lava plains. Asteroid impacts triggered gigantic floods that carved valleys and formed early lakes. Some key points. The Nertiva River Valley and Lake Eza were born during this period. These sites are now explored by Perseverance. Floods were so massive they could be compared to thousands of Volga rivers combined. The magnetic field weakened, but the atmosphere remained thick enough to trap heat, creating a mild greenhouse effect. Essentially, Mars had a wet phase during this time, possibly creating environments suitable for microbial life. The Amazonian era, 2.9 billion years ago to present, marks the modern Mars we recognize: cold, dry, and with a thin atmosphere. Volcanic activity is minimal compared to the past, but massive volcanoes like Olympus Mons still dominate the landscape. Mars's two moons, Phobos and Deimos, are likely captured asteroids, which means Mars's gravitational history is complicated and chaotic. Each moon adds clues to the early solar system's dynamics. Even today, Mars isn't completely lifeless. Ice caps, potential subsurface water, and traces of past activity hint at the planet's dynamic nature. Mars once had water, rivers, lakes, and possibly oceans. Ancient water flowed so massively that it carved huge canyons and valleys. Meteorites from Mars contain organic molecules that resemble microbial fossils. While we can't confirm life, the ingredients were all there: water, chemical compounds, and stable environments in certain eras. Scientists continue to search for proof, and every new discovery could change our understanding of life beyond Earth. Mars's landscapes are extreme. Olympus Mons, tallest volcano in the solar system, 21 kilometers high, 3 times Everest. Valles Marineris, canyon over 4,000 kilometers long and 7 kilometers deep. The northern hemisphere is smooth, the southern hemisphere cratered, possibly due to a giant impact. Mars is basically a natural playground for geologists. Every crater, canyon, and volcano tells a story spanning billions of years. Mars has 2 moons, Phobos and Deimos. Phobos is slowly spiraling inward. Eventually, millions of years from now, it may break apart and form a ring. These moons are likely captured asteroids, which means Mars's gravitational history is complicated and chaotic. Each moon adds clues to the early solar system's dynamics. Since the 20th century, Mars has been explored by robots. Spirit and Opportunity confirmed water existed in the past. Curiosity explores Gale Crater, analyzing rocks and atmosphere. Perseverance collects samples, accompanied by Ingenuity, the first helicopter on another planet. Orbiters provide high-resolution maps of the entire surface. Robots have revealed Mars as a surprisingly dynamic world, far from the cold, boring rock many imagined. Mars is humanity's next frontier. NASA plans crewed missions in the 2030s. SpaceX hopes to send colonists with Starship. China and Europe have ongoing Mars mission plans. Challenges? Extreme cold, radiation, thin air. Solutions? Domes, ice mining, greenhouses. Terraforming ideas include releasing CO2 from frozen deposits to create a mild greenhouse effect. Mars could one day support life, microbes and plants first, humans later. Mars isn't completely static. It has ice caps, seasonal dust storms, and even evidence of ancient rivers resurfacing. Recent studies suggest Mars may have cycles of warming and cooling. If all ice melted, Mars could be covered by an ocean hundreds of meters deep. This means Mars may still have potential for life, naturally or with human assistance. Scientists continue searching for signs of life. Martian meteorites contain organic compounds that resemble microbial fossils. If microbes ever existed, traces may still survive beneath the surface or in sedimentary rocks. New sample return missions may provide definitive evidence. Each discovery could rewrite our understanding of life and where it can exist. Mars is truly a geological laboratory. Every crater, volcano, and canyon tells a story spanning billions of years. Studying these landscapes help us understand early Earth as well. Olympus Mons and Valles Marineris showcase extreme geological processes impossible to observe on Earth at such scale. Mars went from a hot, wet world to a cold desert, but its story isn't over. Humans may set foot on Mars in a few decades. Meanwhile, robots explore, scientists model scenarios, and we can only imagine the red planet's future. What do you think? Could Mars ever become a thriving world again? Share your predictions in the comments.